everyone, Karen here to talk to you about differentiated instruction. For me, differentiated instruction is very important. As a future math teacher, this just means to me that the way math is being taught has and is changing. Prior to the concept of differentiation, math was taught as a one strategy, one approach to problem solving. Usually it was the teacher's approach and you either did it the teacher's way or you were wrong. But with differentiations now, there are different strategies and different approaches to problem solving. A few weeks ago, we talked about the essential question and what was important to us for students in the long run. Something that's important to me is I want students to have a deeper understanding when it comes to formulas. I don't want it to be a regurgitation or memorization of formulas. And one concept in school that I had difficulty with was any number to the power of 0 is equal to 1. I never really got an explanation of why this was the case. It was just a constant. My teachers would tell me anything to the power of 0 is 1. And I discovered a really cool way for students to have a deeper understanding of why this isn't the case. So I'm going to show that to you now. So I actually got this concept from Mathematics Framework for California Public Schools. I believe you can get this PDF from California State Board of Education's website. It's a great tool for any math teachers on ways to have a different approach when teaching mathematics. I highly recommend it. So students should kind of have a basic understanding of exponents for this lesson. Exponents is just repetitive multiplication. And there's actually multiple things students can learn from this idea, but for time's sake, I'm just going to stick with the anything from any base to 0 is equal to 1. So the way students can approach this is they'll see the pattern for the evaluated portion. So when you go in this direction, you're multiplying by 2. And you just keep multiplying by 2 for each box. And then so for our last box, we're getting 16. So then once students recognize that, they're able to go into the opposite direction. So if in this direction it's times 2, our other direction we're multiplying by 1/2, right? Because 16 times 1/2 or divided by 2, it's the same thing. We're going to get 8, and then times 1/2, we're getting 4, times 1/2, we're getting 2, and then times 1/2, we're getting 1. So that's where your concept of 1 comes from when you're doing the base to the exponent of 0. So I did that lesson relatively quickly because we're all kind of mature when it comes to mathematics. But this might be a difficult thing for students to work on, which is fine. Students should struggle in mathematics. There's always been this misconception that students can't or shouldn't struggle when it comes to mathematics. That's actually a concept I learned later on in my career. Most mathematicians spent their whole lives coming up with formulas. So it's fair that students can struggle, through class learning these concepts, because it's important in 2 ways. One, by struggling through it, students are more connected to the problems, and 2, once they overcome the adversity of trying to solve the problems, it's more rewarding in the long run because, they put in the effort, they put in the work. So it's very rewarding to do it that way. So I hope this was helpful. I hope you learned a little bit about differentiation when it comes to mathematics.